here's the first lesson of the second unit for the Advanced Functions course. This lesson you're going to learn how to do long division of polynomial functions. And you're also going to learn about something called the remainder theorem and how to use that to determine the remainder of a division of polynomials without actually having to divide. Before you learn how to divide polynomial functions, let's start and make sure you remember how to do long division of just normal old integers. So I want to do 107 divided by 4, and we'll use long division. And on the right-hand side here, you should see all the steps that we need to do for long division. The steps are basically broken down into divide, multiply, subtract, and then repeat. So we're always going to follow those same 4 steps whenever you do long division, and that's going to apply when we do long division of polynomials as well. Divide, multiply, subtract, repeat. So let's set up our division table. So when we do 107 divided by 4, make sure you understand that 4 is the divisor and 107 is what we call the dividend. So I'm going to be using that terminology a lot. So let me set up my division table by putting my divisor outside of the table and my 107 inside of the table. And if you read the first step, it says what we need to do is look at the divisor, 4, and figure out how many times does it go into the first digit of the dividend. Well, 4 doesn't go into 1. So what we do is, okay, we look at how many times does 4 go into the first 2 digits. How many times does 4 go into 10? It goes into it 2.5 times, but we don't worry about the decimal. We just put 2. And we put the 2 above the 10 at the top of the table. Now what we do is the next step, the multiply step. We multiply the 2 that's in our quotient times the divisor 4 and write it beneath the 10. And then we subtract that 8, 2 times 4 is 8, from the 10, and we get 2. So those are the 3 steps. We divided, then we multiplied, then we subtracted, and now we just repeat that whole process after we bring down the next term in the dividend. So now we have 4. How many times does that go into 27? So it goes into it 6 3/4 times, but we'll just write 6. 6 times 4 is 24. Then we subtract 27 minus 24 is 3, and since there's no other terms to bring down, and 4 doesn't go into 3, we say that that's our remainder. So that's how you perform the long division. And now we need to look at, okay, well, how do we express our answer to this division, 107 divided by 4? There are 2 ways to express it. One way is called quotient form, and in quotient form, we write the division that we did, so the dividend over the divisor equals, then we write our quotient, which was 26, plus the remainder, 3, divided by the divisor. So we would get 26 plus 3/4. That's the answer to our division. That's 26.75. And also, we could have gotten that decimal if we continued the long division by adding decimal places up here and then continuing to bring down. Let me just show you what that would look like. Now, we're not going to do this when we divide polynomials, but just to show you that it's equal to 26.75, watch, if I were to continue the long division, bring this 0 down, how many times does 4 go into 30? 7.5 times, so I'd line up the decimal with this decimal here, so 7 times 4 is 28. Subtract, I get 2. Bring down this other 0. How many times does 4 go into 20? Oh, it goes into it 5 times exactly. 5 times 4 is 20. We have no remainder. See, our answer is actually 26.75, and that's exactly what quotient form gives us, 26 plus 3/4. The other way to write the answer, and let me just get rid of this part. Okay, that's back to what we had. The other way to write the answer is in what's called the multiplication statement. And in the multiplication statement, what we do is we write the dividend as the product of the divisor and the quotient, plus the remainder. So that 107, the dividend, is equal to the divisor times the quotient plus the remainder. 4 times 26 is 104, plus 3 is 107. So it's just another way to express our answer. Let's try one more long division with integers before we try polynomial functions. So let me set up my division table. Put my divisor outside, my dividend inside, and let's run through the 4 steps. Divide, multiply, subtract, repeat. So 22 doesn't go into 7. So we'll figure, okay, well, how many times does 22 go into 75? It goes into it 3 point something times, so I'll put a 3 above the 75. The 3 is now part of my quotient. Now I'll multiply. 3 times 22 is 66. Write it beneath the 75 in the dividend, and then subtract. So this will give me 9. Bring down the next term in the dividend, and then repeat the process. How many times does 22 go into 93? 4 point something times. So 4 goes in the quotient. Then we do the multiplying. 4 times 22 is 88. Subtract the 88 from the 93, and we get 5. And that's our remainder, since there's nothing left to bring down. And don't forget, you can write this answer in 2 ways. We could write it in quotient form by doing the dividend over the divisor. So the division that we did is equal to our quotient plus the remainder over the divisor. The other way to write this would be the multiplication statement. Multiplication statement is our dividend equals the divisor times the quotient plus the remainder. So now that you remember how to do long division of integers, let's try it with polynomials. And it turns out the steps are exactly the same. You're just going to have to remember some exponent rules when you're doing divisions that involve variables. So let's find the quotient of 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3. So we're going to set it up the same way. Put the divisor outside the table. And underneath, we're going to put our dividend. And then we're going to run through the steps. Divide, multiply, subtract, repeat. When we do the division, we do the first term in the dividend divided by the first term in the divisor. We always do that to start off with. So 3x cubed divided by x. 3x cubed divided by x, well, when dividing powers of the same base, you subtract the exponents. So that would give me 3x squared. And I always line up the like terms. So 3x squared, since that's degree 2, I'm going to write it above the x squared term. So that's the divide step. The next step, we must multiply. We multiply what's in the quotient, 3x squared, multiplied by the entire divisor, the x and the negative 3. So 3x squared times x is 3x cubed. Line it up with its like term in the dividend. And then we do 3x squared times negative 3. That's negative 9x squared. Line it up with its like term in the dividend. So line it up with the x squared term. And now we subtract. So subtract the like terms. 3x cubed minus 3x cubed is 0x cubed. That one's gone. And as long as we've done the correct first step, that's what will always happen. The first term will eliminate. Now subtract the x squared terms. So negative 5x squared minus negative 9x squared. So be careful when subtracting a negative. Negative 5x squared minus negative 9x squared is 4x squared. And then we bring down the next term. I mean, we could bring down all of the rest of the terms. It doesn't really matter. But I'm only going to need the next one in my next step, so I'll just bring down the negative 7x. And then we just repeat those steps over and over again. So we look at the first term in the dividend, which is now 4x squared, and divide it by the first term in the divisor, which is x. 4x squared divided by x is 4x. So I'll write it up in my quotient above the x term. Now we multiply. We do that 4x, which we wrote in the quotient, multiplied by the entire divisor. So 4x times x is 4x squared. Write it in the dividend beneath its like term. And 4x times negative 3 is negative 12x. Write it beneath its like term. Then we will subtract. The 4x squareds cancel, and negative 7x minus negative 12x is 5x. And we bring down our last term and repeat the process. First term in the dividend, which is 5x, divided by first term in the divisor, which is x. 5x divided by x is 5. 5 times x is 5x, and 5 times negative 3 is negative 15. Make sure we're always lining up like terms so that when we do our subtraction, we're only ever collecting like terms together. 5x minus 5x is 0, and negative 1 minus negative 15 is 14. That's our remainder because there's nothing else to bring down. And also you should notice that the remainder is always going to be 1 degree less than the divisor. Okay, now we just have to express our answer. We've done the division. We have our quotient, we have our remainder. So remember, there are two ways to express this answer. And I've written those two ways here for you. Remember, this is what we call quotient form, short form QF. And then also this multiplication statement that we could use to check the division, so I'll call that MS for multiplication statement. In quotient form, we always do the dividend over the divisor equals the quotient plus the remainder over the divisor. So in this question, what we did was this degree 3 function divided by x minus 3. And that's equal to, we write our quotient, which we got 3x squared plus 4x plus 5, so we write the quotient, plus the remainder, which was 14, over the divisor of x minus 3. So that is quotient form. The multiplication statement, we write the dividend equals, and then the product of the divisor and the quotient, so x minus 3 and the 3x squared plus 4x plus 5, plus the remainder of 14. So those are the two ways we write the final answer. Okay, example 2, I just have 3 practice questions where we do 3 different polynomial divisions. 1, 2, 3. Let's do A and B together, and then I'll let you try part C on your own. So part A, so we have our dividend and our divisor. We're doing this x squared function divided by x plus 2. So set up our table. X plus 2 goes outside, and underneath the table goes x squared plus 5x plus 7. Okay, and we always start by doing the first term in the dividend divided by the first term in the divisor. X squared divided by x is x. Line it up with its like term. Then we multiply x times x plus 2. So we do the x times the x and get x squared, and the x times the 2 and get 2x. And notice I lined them up with their like terms so that when I subtract, I'm collecting the like terms together. So x squared minus x squared is 0, 5x minus 2x is 3x. Bring down the 7 and repeat the process. First term dividend divided by first term divisor. 3x divided by x is positive 3. Multiply that 3 by the x plus 2, so 3 times x is 3x, and 3 times 2 is 6. Subtract, the 3x's cancel, and 7 minus 6 is 1. That's my remainder. So we can express this answer in 2 ways. Quotient form, we write the division that we did, so x squared plus 5x plus 7 divided by x plus 2. The dividend over the divisor equals the quotient, x plus 3, plus the remainder over the divisor. The multiplication statement, we write the dividend equals, it's a product of x plus 2 and x plus 3, plus the remainder of 1. And this multiplication statement, you can actually expand it back out, FOIL it out, and you can check and make sure it actually equals the dividend. It's a way of checking your answer to make sure it's right. Part B, let's try another one together. 2x cubed minus 3x squared plus 8x minus 12 divided by x minus 1. So we'll write the divisor outside of the table and the dividend underneath. And now we'll do our division. First term dividend divided by first term divisor. 2x cubed divided by x is 2x squared. Now we multiply that 2x squared by x minus 1. 2x squared times x is 2x cubed. Write it underneath the x cubed term. And 2x squared times negative 1 is negative 2x squared. Write it underneath the x squared term. Then we subtract the like terms. The 2x cubes cancel. And negative 3x squared minus negative 2x squared is negative 1x squared. Bring down the next term. And repeat the process. Negative x squared divided by x. Negative x squared divided by x will be negative x. Multiply that negative x in the quotient by the entire divisor. Negative x times x is negative x squared, and negative x times negative 1 is positive x. Then we'll subtract our like terms. The negative x squareds cancel, and 8x minus x is 7x. Bring down the last term, and we'll do this process one more time. First term dividend divided by first term divisor. So 7x divided by x is just positive 7. Multiply that 7 by x minus 1. So 7 times x is 7x, and 7 times negative 1, negative 7. Subtract our like terms. The 7x's cancel. Negative 12 minus negative 7 is negative 5. That's our remainder. And we can express our answer both ways. Quotient form, which hopefully you're getting the hang of now. It is our dividend over our divisor equals the quotient plus the remainder over the divisor. But this time it's plus a negative. So instead of having plus negative 5 over x minus 1, it could just be minus 5 over x minus 1. That's fine too. And also multiplication statement, we write our dividend equals, it's the product of our divisor and our quotient plus the remainder. All right, part C I said let you try on your own, but actually this one has something different in it that I need to explain to you. So we'll do this one together as well. Now, if we look back at part A and B, notice, let's look at the dividend. In that dividend, look at the three terms. There's a degree 2 term, a degree 1 term, and a degree 0 term. Look at part B. There is a degree 3 term, a degree 2 term, a degree 1 term, a degree 0 term. Now, it's important to notice that those terms are all in descending order of degree, which when we're doing the long division, make sure it's set up like that. But also notice all degree terms were represented. There was a 3, 2, 1, and 0. Part C, there's a 3, a 1, and a 0, but there's no degree 2 term. So when we set up the long division, I'm going to have to put a placeholder in for a degree 0 term so that when I do the long division, I correctly line up the terms and subtract the proper terms from each other. You'll see why the placeholder is important as we go through. So let's set it up. Let's put our divisor outside, and underneath, let's put our dividend, 4x cubed. Next should be a degree 2 term, but we don't have one, so I'm going to put plus 0x squared, plus my degree 1 term, plus my degree 0 term, which is negative 12. So there's how we're going to set up the division. Make sure you have this placeholder for the degree 0 term. Now we just run the division like always, making sure to always line up like terms. First term dividend divided by first term divisor. 4x cubed divided by 2x is 2x squared. Put it above the x squared term. Multiply the 2x squared by 2x plus 1. 2x squared times 2x is 4x cubed. And 2x squared times 1 is 2x squared. So do you see why now I had that placeholder there so that I had somewhere to write it underneath? And that so when I do my subtraction, I'm able to correctly subtract it. The 4x cubes canceled, and 0x squared minus 2x squared is negative 2x squared. Bring down the next term, and repeat the process. Negative 2x squared divided by 2x is negative x. Multiply that negative x by the 2x plus 1. Negative x times 2x is negative 2x squared. And negative x times 1 is negative x. Subtract the like terms and the negative 2x squareds cancel. And 9x minus negative 1x is 10x. Bring down the next term and do it one more time. 10x divided by 2x, that's 5. 5 times 2x is 10x. And 5 times 1 is 5. Subtract the like terms, the 10x's cancel, and negative 12 minus 5 is negative 17. So that's my remainder, negative 17. And we can express the answer in quotient form and multiplication statement form. Quotient form is dividend over divisor equals the quotient plus the remainder over the divisor. And once again, if you wanted to simplify this plus negative into just a minus, that's perfectly fine. The multiplication statement, the dividend equals the divisor times the quotient plus your remainder. Example 3 is a little bit of an application question. The volume in cubic centimeters of a rectangular box is given by x cubed plus 7x squared plus 14x plus 8. Determine expressions for possible dimensions of the box if the height is given by x plus 2. Remember volume of a rectangular prism? Well, that's equal to length times width times height. And we know the height and we know the volume. We need to come up with an expression for the length and the width. Okay, well, let's plug in what we have. We know the volume is x cubed plus 7x squared plus 14x plus 8. I don't know the length. I'll just call that L. I don't know the width. I'll call that W. but I do know the height is x plus 2. So let's start by isolating for L times W. So let's divide the x plus 2 to the other side. So if I do this division, I'm actually going to get a degree 2 polynomial, right? Because when I do a degree 3 divided by a degree 1, I'm going to get degree 2. And then that degree 2 quadratic, I could hopefully split into factors that will give me a possible factor for the length and the width. So let's do the division. Maybe we want to do that off to the side. So I'll do that long division just off to the side. I'll set it up over here. So I've got my x plus 2 divisor, and I've got my dividend, x cubed plus 7x squared plus 14x plus 8. It has all degree terms represented, 3, 2, 1, 0, so I don't need any placeholders, and they're in the proper order, so I'm good to go ahead and run the division. X cubed divided by x is x squared. Multiply the x squared by the divisor, and that will give me x cubed plus 2x squared. Subtract like terms. Bring down the next term. 5x squared divided by x is 5x. Multiply that 5x by the divisor. I get 5x squared plus 10x. Subtract like terms. I get 4x. Bring down the last term and do the division one more time. 4x divided by x is 4. 4 times x plus 2 is 4x plus 8. Hey, good, my remainder is 0. That means that the height divides evenly into the volume. Another way of saying that is the height is a factor of the volume, which will allow me to express the volume in factored form perfectly. So now I can replace this, the x cubed plus 7x squared plus 14x plus 8 divided by x plus 2 is equal to the quotient plus the remainder over the divisor. But there is no remainder, so it's just equal to the quotient. It's equal to x squared plus 5x plus 4. So I can replace this quotient with x squared plus 5x plus 4. That's what the length times the width is equal to. And if I want an expression for the length and the width separately, let me factor this x squared plus 5x plus 4 by finding numbers that multiply to 4 and add to 5. That would be 4 and 1. So x plus 4 times x plus 1 is equal to length times width. The x plus 4, we could call that the length. And the x plus 1, we could call that the width. Or the other way around, depends on your perspective, doesn't matter. But the point is, we found expressions for the length and width. So the dimensions of the box would be x plus 4 by x plus 1 by x plus 2. All right, there's one more thing I want to show you in this lesson. This is part 3, the remainder theorem. So I'll read this definition to you in words, but I'll explain it to you after. It's probably more simple than it appears here. When a polynomial function p at x is divided by a binomial x minus b, the remainder can be found by evaluating p at b, the value of the polynomial function at b. And when it's divided by ax minus b, find the remainder by evaluating p at b over a, where a and b are integers. So this only works if a and b are integers. Now what does this mean? It just means if we're dividing a polynomial by a binomial, we can find the remainder just by plugging in the 0 of the binomial into the polynomial and evaluating. So what makes x minus b 0? B would make it 0. So evaluate p at b. What makes ax minus b equal to 0? Well, if we set ax minus b equal to 0 and solved, we would get ax equals b, x equals b over a. B over a is the 0 of the divisor. So we take that, evaluate the polynomial function at that value, and we figure out the remainder. So 3a says use the remainder theorem to determine the remainder when this polynomial is divided by x plus 1. So we can figure out the remainder using the remainder theorem by just plugging in the 0 of the divisor into the polynomial function for x. So what makes x plus 1 be 0 would be an x value of -1. So let's evaluate p at -1, and that will tell us the remainder. And we didn't even have to do any of the division to figure out the remainder. So 2 times -1 cubed plus -1 squared minus 3 times -1 minus 6. And let's simplify this. -1 cubed is -1 times 2 is -2 plus -1 squared. That's 1, minus 3 times -1, it's positive 3, minus 6. So if we evaluate this, -2 plus 1 is -1, plus 3 is 2, minus 6 is negative 4. So if we were to do this polynomial divided by this divisor, we would get a remainder of negative 4. It doesn't tell us anything about the quotient, but it tells us the remainder, which is going to be really helpful later when we're trying to factor polynomials. We're going to need to be able to figure out what makes the remainder be 0, so it's going to be useful to be good at the remainder theorem to do quick checks. Let's verify that the remainder would be negative 4 by actually doing the division. So let me set up my division table by putting my divisor, x plus 1, outside the table, and put my dividend, 2x cubed plus x squared minus 3x minus 6 under the table. And do I need any placeholders? Nope, I have degree 3, 2, 1, and 0. All degrees are represented, and they're in descending order, so I'm good to go. 2x cubed divided by x is 2x squared. Multiply, I would get 2x cubed plus 2x squared. Do my subtraction of like terms, I would get negative x squared. Bring this one down, and repeat the process. Negative x squared divided by x is negative x. Multiply that negative x by x plus 1. I get negative x squared minus x. Subtract my like terms, I get negative 2x. Bring down my last one, my minus 6, and do the process one more time. Negative 2x divided by x is negative 2. Multiply that negative 2 by x plus 1. I get negative 2x minus 2. Subtract negative 6 minus negative 2 is negative 4. Notice the remainder we got is exactly what we found when we did the remainder theorem. It's just we didn't have to go through any of the division when we used remainder theorem. Now the division gets us the quotient as well, so if we wanted the quotient we would actually have to do the division, but if we're just interested in the remainder, we don't have to do the division, we can just do the remainder theorem, which says plug in the 0 of the divisor for x into the polynomial and it'll tell us the remainder. Example 4, another practice of the remainder theorem. Use the remainder theorem to determine the remainder if this polynomial is divided by 2x minus 3. If we want the remainder, all we have to do is plug the 0 of 2x minus 3. So let's figure out what makes this be 0. Solve that equation for x. I would get 3 over 2 is what makes it be 0. Plug that in for all the x's into the polynomial function, and that will tell me what the remainder would be if I were to do the division. So let's evaluate p at 3 over 2. So 2 times 3 over 2 cubed plus 3 over 2 squared minus 3 times 3 over 2 minus 6. And to get some good practice working with fractions, let's evaluate this without a calculator. So make sure you follow BEDMAS. Let's do the exponents first. So 3 over 2 cubed, I would have to cube the 3 and the 2, and that would give me 27 over 8. Plus, now I have to square the 3 and the 2, gives me 9 over 4. Minus 3 times 3 is 9, so minus 9 over 2, minus 6. I was going to multiply this 2 by 27 and get 54 over 8, but I could just reduce 2 divided by 8 is 1 over 4. And I'm going to want to collect these 4 terms together and write it as a single fraction, so I'm going to need a common denominator. So this first term is 27 over 4. The second term is 9 over 4. I can rewrite 9 over 2 with a denominator of 4 by multiplying top and bottom by 2, so minus 18 over 4. And rewrite 6 with a denominator of 4 by multiplying top and bottom by 4 and get minus 24 over 4. Now they all have the same denominator of 4, so I keep the denominator and add and subtract the numerators. So 27 plus 9 is 36, minus 18 is 18, minus 24 is negative 6. So I get negative 6 over 4, which of course I should reduce to negative 3 over 2. So that would be the remainder if I were to actually do the division. Example 5, this is a good question. It says, determine the value of k so that if I were to divide this by this, I would get a remainder of 8. So I can set myself up an equation. I know the remainder is equal to the value of this polynomial with the 0 of this plugged in. And what makes x minus 2 equal 0? An x value of 2. So if I substitute that x value of 2 in for these x's, it should make the equation equal 8 for it to have a remainder of 8. So let me set that up. I can write 8 equals 3 times 2 to the 4 plus k times 2 cubed minus 7 times 2 minus 10. Now I have to figure out what value of k makes this true. So 8 equals 3, 2 to the power of 4 is 16, plus 2 cubed is 8, so k times 8, I'm going to write that as 8k, minus 14 minus 10. 8 equals 3 times 16, well 3 times 10 is 30, 3 times 6 is 18, so that's 48, plus 8k, I'll collect those two together, that's minus 24. 48 minus 24 is 24. Let me subtract this 24 over. 8 minus 24 is negative 16. And last step, divide the 8. I get k equals negative 16 over 8, which is negative 2. So what we have just figured out is if this k was negative 2, when I divide that polynomial by x minus 2, the remainder would be 8. All right, that's it for this lesson. Make sure you try out these polynomial division questions. The only way to get good at this division is by actually practicing a bunch of them. And then the next lesson, we're going to learn a shortcut that works for certain types of polynomial division called synthetic division. So stay tuned for that.